Question 4, 25 centimeters cubed of air at 1 atmosphere is expanded at a constant temperature until the pressure has fallen to 0.25 atmospheres. Find the new volume. So again, we can just use the combined gas law, well, just Boyle's law, in fact. P1 V1 is equal to P2 V2. Here we're trying to find V2, which is just P1 V1 over P2. So the initial pressure is 1 atmosphere. The initial volume is 25 centimeters cubed. The final pressure is 0.25. Well, hopefully this isn't too hard. The pressure's gone down by a factor of 4, so the volume will go up by a factor of 4 to 100 centimeters cubed. But part B says calculate the number of moles of gas in this arrangement. As soon as we want the amount to be in numbers of moles, we're going to have to be much more careful with units. We're going to be using the full ideal gas law. PV is equal to nRT, and we can rearrange this to N is equal to PV over RT. But we better make sure that we've got the correct values in here in terms of the units. Now I'm going to need a temperature, aren't I? So I'm going to edit the question so it has a constant temperature of 293 Kelvin. Let's pick a number. And so my number of moles of gas in this arrangement, N. So first of all, the pressure. Well, here I'm in units of atmospheres. That's no good. So I need to convert from atmospheres into pascals. So I know that 1 atmosphere, I need to multiply by the conversion factor, which is the number of pascals per atmosphere, which is 1 times 10 to the 5. Then the volume I've got as 25 centimeters cubed, but I need to convert this by getting rid of the centimeters cubed and replacing it with meters cubed. So I'm going to need to multiply by the number of meters cubed in a centimeter cubed. So 1 meter cubed is 1 million centimeters cubed. So that's a 1 times 10 to the minus 6. The ideal gas constant is 8.31. I don't need to worry about the units of that, so I'm not going to write them down. But the temperature I do need to use, and I need to be in absolute units of temperature. I already am, so I'm going to multiply that by 293. So this is obviously a fairly long-winded way of writing out this calculation with the unit conversions in. You might choose to write it a bit in a better way than this. So 1 times 10 to the 5 multiplied by 25 times 10 to the minus 6 divided by 8.31 times 293. That gives us the value of the number of moles of 1.02. So 1.0, when I write it to two significant figures, times 10 to the minus 3 moles.